Peter, we meet again at EUPVSec. Obviously, some of the most significant developments going on at the moment are around metallization, the issues to do with the rising costs of silver. Give me an update, please, on what you're doing in the face of all of this and the need for cost competitive products and cost reduction strategies.
It's clearly the topic of the fair. And there's two ways to look at it. We look at the short-term actions that we can take and the long ones. So let's deal with the short-term first. People are pushing immediately to reduce their usage of silver, to reduce their reliance. So that means they're looking at pattern redesigns to minimize finger width and reduce the amount of silver they're printing down on substrate. They can do that tomorrow. There are products, PV17X, for example, that enable that very fine line printing. And a lot of the technical teams of our customers are working on that immediately. We can then go to the next step. So silver has some fairly unique properties, so it's very difficult to eliminate it from certain parts of the cell. So let's look at it intelligently. Let's leave the silver where it's useful, probably in the front fingers, and then look at different metallurgies, or shall we say, not being as so heavy-handed with the silver, in order to look at the bus bars and so on. And that leads you on, that a lot of this is interconnected. If you're going to decouple the fingers from the bus bars, you probably have to start looking at back contact wafers, back contact cells through metal wrap-through type applications. And that's another level of complexity for the customer to grasp, not only from the cell maker, but then downstream to the module maker, because you need capacity of back contact modules, or people who are capable in back contact modules, to take these. So that's a short and a medium-term view.
Yeah, is that the complexity issue is one thing, but ultimately by going to back contact, you are significantly reducing, or potentially the significant reduction in the cost of production. So the complexity is not adding cost. At the end of the day, it's taking cost away.
Absolutely right, and that's essentially, I guess, what our customers at the module end, their roadmap lends itself to. Because by going to back contact, you're almost getting into a pick and place type arena for assembling your module, whereas today we try and wrap this ribbon round, very complex, and you're breaking cells. So without doubt, that's a higher volume, and by higher volume, it'll be lower cost for them. So it's a win-win for all of us. But there are properties within the paste you have to change to enable them to do that. Because as they go to these back contact wafers, they're not necessarily doing a like for like in the design as they would today in a conventional wafer, where you have probably continuous bus bars. So in the next gen, they will go to non-continuous bus bars and allow the ribbon to make the full electrical contact. And so the material that you're using for these bus bars have to have higher adhesion, they have to have improved solderability and so on. So we have our part to play in enabling those back contact modules to get going in the market.
Now, obviously, we're seeing potentially new designs that are coming through. Where's the challenge for you then in selecting the right type of product, especially as we are trying to eliminate or reduce as much as possible the use of copper? The use of silver.
Silver, yeah. I mean, you're right. Chemistry is a big player here because we're using silver purely as conductivity. It tends to be on the surface of the conductor, whereas there's a lot going on under the surface in making good adhesive contact, making electrical contact on the junction and so on. So as we move forward, we need to make efficiency gains, and I don't just mean pure cell efficiencies, but making them more able to do their job more efficiently, and you get higher values out of the adhesion and the efficiency and so on. And so when you do that, and you probably take away the primary intention of the material system, you can then look probably at different metallurgies or reducing the amount of silver on the surface. So you could look at a metallization as almost a two-component thing. It's what's going on down below and just the pure conductivity on top. So there's a lot of chemistry, complex chemistry involved.
I mean, we've seen here at EUPVSec a swathe of new metallization pastes come on the market. Some are obviously for the metal wrap through for new cell designs, but others are looking at the low cost manufacturing route. What's happening there? And things like low temperature. What's going on?
Great. And actually I would split those into two different markets. The low-cost manufacturing route. So what are we trying to do? We're trying to enable our customers and our customers' customers, who are the module makers, to reduce their costs. And what can we do? Essentially what they're doing is they're soldering, they're trying to pick and place. We're trying to reduce stress in the cell, we're trying to make them more solderable, we're trying to reduce the footprint of our materials, but they still have the functional output. So this is essentially a summary of what we've said already. If we move into the low temperature materials, those are materials that you could almost say need to have similar properties of what we've been talking about already, but they're for the thin film market, where you have TCO on the surface and you're trying to make a contact with TCO. So they still need to make an efficient contact to the TCO and have excellent conductivity to get the power out, but they can't destroy the PN junction, so they have to operate at about 200 degrees. Many products we have in that area, and you could ask exactly the same questions about those products. Is we need to minimize our reliance on silver for them, so we're doing the same things. We're trying to make them more conductive, and to do that you need to make them, if you like, a more dense composition, even though you're only processing them at 200 degrees. Not an easy thing to do, but you can do it, and if you can do that, then you can minimize the amount of material that you're using on any thin film application. So both are pushing hard, especially with the cost reduction we've seen this year.
Now, you're well aware there's now growing talk, and especially here at EUPVSEC, about completely going in a new direction, away from silver to copper. Is that a concern for you, or what's the impact? Because so many people are familiar with you in this field.
Absolutely, and if we move to a totally different metallurgy, then you're right, it's going to be a radical change for the industry because the processing will have to change. We have a lot of experience in using alternative metals in the hybrid industry, for example. Firing in nitrogen pure coppers at high temperature, making very conductive films is normal business to us. So we have this ability to create very novel materials if the industry requires them. If the cost of ownership, and this is the big question, the cost of ownership enables them to change the processing to something like an inert atmosphere in nitrogen and enable us to get the conductivity out of these different metals. Copper's one of the ones that people talk about. There are probably some special precautions you need to take with copper because essentially it's a poison to the cell. But to me, that's a short-term issue, that's an R&D challenge. They will get through that. The fundamental issue being, you quite rightly point out, copper's more readily available. And so maybe the industry will need to go there, depending on where the price of silver goes to in the future.
Now, a final question for you. The activity, the intensity in new pace and composites that's going on, I mean, is this just the start of that? Have we got a lot more to come, or is this like a time when we've just had everybody come out to meet the growing demand, and these pretty much will settle down as the products? Or are we expecting this to ratchet up, shall we say?
Yeah, market intensity, absolutely. Yeah, you're absolutely right. In this last year, because of what's happened to prices and costs in the market, everybody's had to come out rapidly and do their bit, really, because we all have to contribute to reducing costs in this whole manufacturing chain. So I don't expect it probably to be as intense as it's been in the last 18 months, but I think it's given us all a different view of our roadmaps. Before we were looking at efficiency because we're all very clever technical people. Now we're looking at reducing costs for our customers. And no matter how clever and technical you can be, if you can't implement it cost effectively, they won't use it. So that is the main thrust of all technology roadmaps now, and the faster we can bring out cost savings for the customer, the more effective they will be, the more profitable they will be, and the more successful we will be.